Are we living inside a black hole? Imagine this. Everything you see, feel, and experience might not be what it seems. What if our entire universe is inside a black hole? Sounds absurd, right? After all, black holes are supposed to destroy everything that falls into them. But recent theoretical studies suggest something much stranger might be happening. These ideas challenge our understanding of space, time, and even the nature of reality itself. Let's dive deep into this mind-bending topic and see why some physicists think our universe could have started as the interior of a black hole in a larger cosmos. The paradox of lost information. When a massive star collapses under its own gravity, it can form a black hole. A black hole is an extreme region of space where gravity is so strong that nothing, not even light, can escape beyond a boundary called the event horizon. Inside this horizon, matter is believed to collapse into a point of infinite density called a singularity, where the known laws of physics break down. But there is a huge paradox here. According to classical physics, once something falls into a black hole, all information about it is lost forever. The black hole keeps only three properties: its mass, its spin, angular momentum, and its electric charge. Everything else seems to vanish. However, quantum mechanics tells us that information can never be destroyed. This principle, known as unitarity, says that in quantum evolution, information must always be preserved. Stephen Hawking proposed that black holes emit what is now called Hawking radiation and could eventually evaporate. But if a black hole disappears completely, where does all the information go? This is known as the black hole information paradox, the holographic principle. To solve this paradox, Dutch physicist Gerard T. Hooft suggested something revolutionary. Perhaps the information about everything that falls into a black hole isn't lost but instead stored on its surface like a kind of two-dimensional code. This idea led to the holographic principle, which proposes that all the physics happening inside a three-dimensional volume can be fully described by information encoded on its two-dimensional boundary. Imagine a box. Inside, particles move, interact, and events occur. The holographic principle suggests that everything happening inside could be described just by writing information on the box's surface. Some physicists believe this principle could be the key to unifying gravity with quantum mechanics, potentially leading us to a long-sought theory of quantum gravity. Could our universe be inside a black hole? If this principle applies to black holes, why not to the entire universe? Some scientists suggest that what we see as the Big Bang might have been the rebound of matter inside a black hole in a larger universe. According to this idea, when matter collapses into a black hole, it could undergo a quantum bounce instead of collapsing into a singularity. Under certain conditions, that bounce might trigger an expansion similar to the Big Bang, giving birth to a new region of space-time, a baby universe. From the outside, that black hole would look like any other. But from the inside, the baby universe would have its own matter, energy, and physical laws. Why do scientists take this seriously? For one, the size of the observable universe, marked by the Hubble radius, is surprisingly similar to the Schwarzschild radius that a black hole of the same mass as our universe would have. And there's more. A recent study using the James Webb Space Telescope observed hundreds of very distant galaxies and found that most of them rotate in the same direction. Out of 263 galaxies analyzed, about two-thirds spin clockwise, while the rest spin counterclockwise. If the universe were completely random, we would expect half of them to spin one way and half the other. But that's not the case. This strange preference for a particular direction might indicate that our universe has an inherited axis of rotation, a possible trace of its birth inside a rotating black hole. Subscribe for more mind-blowing science. If you're enjoying this journey into the mysteries of black holes in the universe, make sure to hit the like button and subscribe. We release new videos every week exploring the deepest questions about space, time, and reality. Your support helps us bring you more fascinating science content. Baby universes and cosmic evolution physicist Lee Smolin even proposed that universes could reproduce through black holes. In his theory, universes that are better at producing black holes would create more offspring, leading to a kind of cosmic natural selection. This would mean our universe might be optimized to form black holes simply because it descends from previous universes that were also good at producing them. It's a wild idea, but it elegantly explains why our universe has the right conditions for complex structures like galaxies, stars, and life to exist. Do we have any proof? Right now, these are still speculative theories. We don't yet have direct evidence, but they provide a possible solution to some of the deepest problems in physics. What happens inside a black hole? Why does our universe seem so finely tuned for complexity? And could the Big Bang itself have been the birth of a new universe inside a black hole? Researchers are looking for indirect evidence in the cosmic microwave background and the large-scale structure of the universe. If future observations match these predictions, we might finally understand whether black holes are endings or beginnings. The ultimate implication, if true, this would mean black holes aren't just cosmic graves. They could be cosmic wombs, creating new universes in an endless chain of creation. Our entire reality, space, time, and everything in it, might have begun as a bounce inside a black hole from another universe. Even the flow of time as we know it might be a property inherited from the parent black hole. The arrow of time, always moving forward, could be a legacy of the conditions inside the black hole that gave birth to our cosmos. This hypothesis isn't proven, but it's a serious possibility supported by strong mathematics. It connects general relativity, quantum mechanics, and cosmology in a fascinating way. So could we really be living inside a black hole? Or is our universe something even stranger that we can't yet imagine? If you enjoyed this video, make sure to subscribe and explore the other videos on our channel. Every week we dive into the biggest mysteries of the universe, so stay tuned for more mind-expanding science. Thank you for watching.